Our topic for today is similarity in right triangles. The theorem states that if an altitude is drawn to the hypotenuse of a right triangle, the new triangles formed are going to be similar to each other as well as to the given triangle. So in other words, if you have triangle Z, X, Y, and you draw an altitude from the vertex of where the right angle is towards the hypotenuse, all these, the three triangles, this right here, that small one, is now going to be similar to this medium-sized one as well as the overall right triangle. For better visualization, I made a triangle for you as a model. So this is your original triangle, the big one. That's your original right triangle. And this is your altitude. As you can see, I have the pink and the blue that have been pink and blue right triangles that have been made out of that altitude. So let's go ahead and detach them just to show that your pieces are going to be similar. So that's one right there. And this other one right here is going to pull out like such. And this is going to be like such. So those three triangles are going to be similar now. And all the similarities and the proportional sides and the congruent corresponding angles are going to apply on this one because your three triangles are similar. Because the three triangles are similar, the following proportions will happen. C over B will be equal to B over N. So that's this one. In the same way that this will happen, C over A is equal to A over M. In the same way that N over H will be equal to H over M. So what is a geometric mean? The definition of geometric mean of two positive real numbers is the positive number x which satisfy a over x equals x over b. Therefore, we are going to have x squared when you cross multiply x times x squared, a times b, ab, and thereby to solve for x, you will get the square root of a times b, and that is the definition of geometric mean. So for our first example, I have here a right triangle and the altitude h, and this side right here is 9 and this side right here is 4. So how we're going to solve this is, I would call this as my n. So in my example, that was my n and this was our m. And so I'm going to write n over h is equal to h over m. And now I'm going to substitute, and this would look like 9 over h is equal to h over 4. And that is going to look like h squared is going to be 9 times 4. And that is going to be h squared is 36. Therefore, my h is the square root of 36, which in this case, h is 6. Okay, now we have a triangle that is a little bit challenging because it's upside down. However, we know that our 16 is our C. We're looking for our M, and we know that this is our, if I'm not mistaken, we label that as our A. So now, we are going to use the C over A equals A over M, right? So this side over this side is equal to this side over that side. So now, we're going to substitute, and this would look like 16 over 8 is equal to 8 over m, and we're going to cross multiply. So now we're going to multiply this and divide it by that, and that will be our m. So this is going to be, oh sorry, my bad. Let's put an arrow. Okay, so that's going to be, my m is 64 divided by 16. And when m is equal to 64 over 16, therefore our m is 4. Okay, example number 3. Again, another upside down similar right triangles. This right here, the hypotenuse of the biggest or the original right triangle is 54, so that will be our C. We'll call that our C. I am going to call this I think this was our N. But we have a little bit of a problem here because we're not looking for this side. We're looking for this side. Because I'm looking for that side, I need this piece. We need this piece. So because we need this piece, this is a simple math of subtraction. So 54 minus 48 for this one gives you 6. Now that we have the 6 there, we can already do our ratio and proportion. So I'm going to do C over B is equal to B over, in this case, M. That's N, then this is M. And we're going to substitute. So our C is 54. Our B is missing. Another B here is missing, but our M is a 6. So we can do geometric mean on this one. So cross multiply, we will have B squared equals 54 times 6. So B squared is equal to 324, and so my B is going to be the square root of 324. And so we need to simplify that by doing this. 324 divided by 2. That is going to be, so 324 divided by 2 is 162. Divide by 2 is going to be 81. And 81 is, circle that, this is 9 times 9. I can already stop there because I can see that these two are already perfect square. Therefore, I can go back and do let's do it here on the side. So my B is equal to big radical. Arrange this from least to greatest. So 2 times 2 times 9 times 9. This will go out because that's a perfect square. This will go out because that's a perfect square. And only 1 is going to stay inside, the number 1. So this is going to be B is equal to 2 because 4 has a square root of 2 and 81 has a square root of 9. Just to emphasize, there is really a square root of 1 inside, which is still a perfect square of 1. Therefore, the B is just 18. That's your final answer. Last and final example. So this figure is asking to find the C. So this is a little bit not like direct way of doing it because we are looking for the C, but then we're given the M, the H, and the N. So we're going to have to use M over H equals H over N. Okay. And so we will have 9 over 15 is equal to 15 over N. And again, we're going to cross multiply this and divide it by 9, thereby making our N equal to, so after you cross multiply and divide it by 9, you're going to get N equals to 25. You are not done. So after getting the 25, according to the problem solved for C, therefore, C is the sum of 9 and 25, making it become C equals 34.